we are presenting today about space architectural design. Firstly, in the opening will be for the Ece. She will continue. The field is yours. Ece.
Hi. So this is the global exploration roadmap, which is presented by 14 different agencies coming together, and clearly we are going to Mars. Therefore, we will try to present our concept of habitat there. Before getting there, what are the considerations while putting a human being to outer space? The space is a very, very extreme environment, and it shares all the characteristics of extreme environment as such: hardship of reach, autonomy, isolation, and confinement. If you can pass while I'm talking, by the way, lack of external stimuli, social monotony, lack of resources, hardship of evacuation in case of emergency. And in Mars, we see all those things, not all those things actually. We have some natural life cycles, and we have gravity there, 1/3 of the Earth. But the hardship of evacuation and the getting there part and carrying a mass with us is really problematic for Mars. And to make human beings there to provide them well-being, we first should look at the levels of space habitation as Lockhart presented. The first one is survival. In survival phase, we only need protection, a case to let humans breathe and just live. These are the first missions we have made to space, and later on we get to performance. And at that point, we need the human being in there to be able to do some tasks. Therefore, he or she should have some comforts, and that means that the next missions we have made, but also some other missions such as like cargo delivery or something like we just go and come back. It's just a trip. And from there we get to the habitation phase, habitation level, and at that part we need all aspects of life as people are gonna live there. And in adaptation level, this is for much longer time span, and in that time span it's being discussed to change the planets for humans, or change the human for the planet. So it can be seen as a really extreme subject, but all those things are being discussed in a longer time span. So how do we habit a human in Mars? How do we design a habitat there? We can continue. We try to put some bullet points for us to be both careful of and both to provide for humans there. And I mean, there is much more, of course, but among those things, we first are focused on, next slide. We first focused on those points, and in our design, we'll be talking about those bullet points in our design today. So how should we look at the environment of Mars? How is the environmental conditions there? The next slide. So here we see a table of some different space environments again, and the darker the part is, the more extreme the conditions are there. So Mars surface is not the most hostile place for human beings. We have some issues there. mostly about getting there again, and communication delay, and also not yet experienced dilemma of losing visual connection to Earth. And our engineer will talk about some of the radiation concerns before passing to this to our design.
Hi, my name is Serdar. I am aerospace engineering student at Turkey from UTE University. I want to talk about some effects about radiation. We have some visual order in the motion dynamics that we need to take. One of them is the radiation factor. The Martian surface conditions more radiation than the Earth's environment. The radiation level is 13 U served hourly when the solar is at minimum level. When the solar is at its maximum amount, it can increase to 2 times this value. If people living in the Martian environment spend an average of 3 hours outside the habitat every 3 days, they add up to an average of 11 millisieverts of radiation increase per year. The surface of Mars is covered with soil that can be isolate us from this radiation effect, and a 5-meter soil layer can create a production structure that will be reduce the amount of radiation to the same level as the Earth. Estimates doses for a 6-month stay on the International Space Station are 1.0 beyond 1.5 rams. These values increase up to 2.5 times when the Martian environment is considered. Radiation levels typically range from about 1.5 to 3.5 millisieverts per year, but can be more than 50 millisieverts a year. In our architect design, we focused on the importance of the daylight for human. In this process, in order to provide radiation protection, we searched for a material that will allow daylight to pass through in our building and also provide active radiation protection. At this point, lead glass and alloy materials appeared.
We needed materials that can provide some kind of radiation protection, surely. And if we can move to the design altogether. Therefore, we wanted to have lights, but we needed to be protected from the radiation. We needed to search for methods, search for materials and building methods to let us do. And we wanted to provide humans their natural circadian rhythms and provide them some external stimuli, as there wouldn't be any external stimuli if we just put them on a closed box with same temperature and no wind all day. Those kind of things would not psychologically good for human. And to provide those kind of stimuli, we try to use the natural light cycle of Mars because it's so similar to Earth. And we also try to have different environments within the habitat to provide some various temperatures and light conditions, etc. And for radiation protection and to have a breathable and pressurized volume, we try to use, we have used this hybrid shell system with regolith on the top and an inner translucent material, which we'll be presenting soon. And we use that hybrid system because of we wanted to use in-situ materials. So for the massive part of radiation protection, we wanted to use the Martian soil, Martian regolith. But as it's both toxic and wouldn't be enough sufficient to have a bondage, we also have another material that we could expand to fit in the printed shell, which is autonomously constructed before humans get there.
Okay, then I will continue with our design. We had a design, so we processed on it where we put a lot of new ideas on it, and I will talk about this and talk about how we progressed on it. We worked on some biomimicry, and one of it was the motif of the spherical Fibonacci lattice as combine it to the honeycomb shape. As we combined these two, one part from here and one part from here, we come up to this shape and worked on this shape and reached out to the perfect sphere, and we cut out it to make a better dome shape. But this dome shape we use for inflatable structure. So we will have a different construction, and we will use inflatable structure in it for having a flexible movement all around the Mars when we have any research and work, investigation in any place of it. So in this project, we have intention of a flexible neighboring system. As we have neighboring system on the Earth, we wanted to move this system to the Mars. We have a large area, and inside of it we can have more than one habitats. So every place will be among to another person that can make a neighborhood system. So it can be extendable in different shapes. This inflatable system will be double inflatable system. So in the middle we will pressurize and pressure air can cover and protect human from the radiation. And also there will be some system that can transfer the oxygen, carbon dioxide of the outside to inside as oxygen. And we have this concept of the dimensions. At the top we have the higher matter, because the horizontal rays of the sun are more harmful, so we can have more air pressurized here, so will be protected from outside. So the bottom part will be narrow. These are a concept of how we can extend in the neighboring. We can extend in different shapes. As a new idea we have put on our project is the exterior shell. As I told you that we have inflatable interior material, it's double, but in the exterior we will use, as Ece told, we will have 3D printing shells. We have these 3D printing shells inspired from the hermit crabs, as hermit crabs can have a lot of different shapes. And this animal will take shape according to its exterior shell. So our project is exactly to come up to this idea from this concept, this second biomimicry, third biomimicry. As the interior, we have some sketches on new how extended we can use for exterior 3D printing shells. There can be a lot of different types according to the need of the people who will move to Mars, according to the number and population, or according to the place and the topography of the Mars. We can have different shapes of exterior shell. This is one of the shell that we worked on. There are 3 components here, as you see. This can be designed for a large topography area. And as you see at the exterior, there is a 3D printing shell. In the middle, there will be like a water tank that will be transparent, as Serdar told us that alone material can be used, and it will be transparent and taking the horizontal rays in the safest way. And also As you see in the third part, there are habitats in different corners. We have inspired from the Turkish hammams. As from the history until now, this shape has been used. So as you see, these are the holes. So if we do like a 3D printing at the Mars with the regolith, we can have some small holes with the material of alone to have the lights inside. So these are the some inspiration from the old historical buildings. We have thought how to make it for our habitat. We can open some parts from here or here. And as you see, this inflatable material can be placed under a shell. This black one is our 3D printed exterior shell with the opening of the glasses as inspired from the Turkish hammams. This green material is alone. It's aluminum nitrate material, and inside can be like a green algae material. As algae materials is also converting carbon dioxide to oxygen and also making inside hot and prevent inside from the radiation of outside. We have these three important specialty of this thing. We fill our glasses with this material, and when we fill it, we can have safest light. And as you can see in the bottom part, there are like vertical lights can be safer, and the horizontal one can be more dangerous. So we can have smaller windows and top part. The inside we have like greenery area because we have concept of neighboring. The neighboring area we have habitats in the gardens, so everyone can grow up their plants and walk inside. Like we didn't want to have a lifestyle on the Mars when we want to go to our neighbor as wearing our space suit. So it's very boring thing. So we make a larger dome and small domes inside as for habitats, so human can walk to neighbor without a spacesuit and grow plants like a home on the Earth. These are some other views, and this. So this is end of our presentation. Thank you. This is our contact. You can contact us on our email on social medias. Thank you.